Thank you very much, Ian, and thank you to Linknode for the opportunity to come and speak to you today about an example of renewable energy. We're going to concentrate on offshore wind. I'm sure most of you in this room will have come across or heard a little bit about the subject in the last 3 or 4 years and the role that it does actually play. And so what I'd like to be able to do is, just before we get into the detail of the renewable energy developers' perspective, if I could just indulge a little of your time to talk about the Crown Estate. So for those of you in this room who may not be as familiar with the role of the Crown Estate is a public sector entity. It's quite an old establishment, established in the 18th century under George III, where the assets of the monarch were effectively put into a trust, and the proceeds of that trust, the land management, the asset management of that trust, is paid directly to Treasury each year. Over the last 10 years, we've returned around £2 billion to the Treasury, and last year around 240 million. You could say we're 100% taxpayer. But ultimately, the Articles and Memorandum of Association of the Crown Estate are governed under Act of Parliament. In fact, our accounts are returned to Parliament, and we're there to ensure that we turn the estate to account for the good of the public purse. We're not part of government. We're not the planning authority. We're here as the asset manager of some of this country's most precious assets. This is just a snapshot for you in the offshore world environment of the assets that the Crown Estate manage on behalf of us all. And here you'll see quite a myriad of infrastructure that, in respect of the planning world, it's critical that we get this important planning aspect correct. Look at all those different colours of activities, those different competing construction type activities, and therefore understanding its impact in a real-time basis is really, really quite critical. I've heard, as we all have over the last hour, some interesting challenges around data sharing, around what is the role of digital technology in the planning world. Well, digital technology in the world of the Crown Estate is really, really important. And over the last 3-4 years, we've started to develop a MARS system, a marine resource system, to allow us to spatially plan the seabed, to turn the estate to account in a commercial way. Because imagine you look at a field, and Chris is going to show you some of the power of the technology that these guys have developed. You can see the undulations of the ground. You can see the buildings on which these assets are going to lay in front of. And visually, it's easier to see. If you look out to sea, what do you see? Not a lot. Yes, you see the virtual landscape, you see perhaps oil rigs or peninsulas, but under the sea, it's quite hard to understand the topography of the seabed. And over the last 3 or 4 years, one of the most largest offshore wind leasing rounds that has come to pass is called UK Round 3. It's called that because, strangely enough, it's the 3rd leasing round. And if nothing else, hopefully it delivers, huge green renewable energy for all of us, but it has delivered data. The Marine Data Exchange, £250 million has been spent by developers getting to the point of consent. That is all at risk. Getting your planning consent put together and submitted. Average cost of putting a consent together for a wind farm is 20 to 30 million pounds. Think of all that at-risk capital. Developers, really, really important for them to get a return on their investment as quickly as possible, to keep up along the timeline of the stage of investment in order to get a return for the most up-to-date technology. So these are very, very big schemes. I've talked about what is the role of the Crown Estate. Well, we do have a role in understanding how the assets and the infrastructure developments of the seabed all come together. So we work with local government, devolved administrations, local planning authorities to look at that spatial planning. We make available the resource tools that we've got. We funded the Marine Data Exchange, which is basically developers giving us the data that they've spent £250 million collecting for the good of stakeholders, government organisations, government bodies. Because the power and the value of data in a non-commercial way, and that's the difficulty I'll come on to in a minute, is really, really key and powerful. Where it does get harder, and I hear what the gentleman said earlier, is when you're in a commercial world where data has a unique value to the developer, it is harder to share. And I'm sure where public bodies or public entities may have a reluctance to share data, it's because they feel a precious sort of link to it, or it has value to them. And one of the things we're kicking off at Crown Estate with the developers, it's been a bit of an uphill battle, but we're getting there, is something we call Sparta, which is taking the operational data of wind farms and putting it into a database, anonymising it to benchmark performance of turbines on sites with developers on maintenance and operation regimes. That is some of the most sensitive data you will have around, not just from a supply chain point of view, but from a site point of view. But people are starting to think and appreciate the importance of data. So we have a team in London and in Edinburgh. We have 35 energy specialists in Edinburgh, and we have 50 in London. Crown Estate employs about 400 people over 4 estates. First estate is our marine environment, because we have asset management, ownership stroke rights under the Renewable Energy Act out to 200 nautical miles-ish. Not obviously all the way around, or else or in Paris, which would be a bit embarrassing. But out to the continental shelf for renewable energy. Hydrocarbons, of course, is a reserved matter for the government. We get involved in understanding and supporting, as a trusted advisor, Department of Energy, particularly in respect of energy market reform. Although we aren't writing energy market reform, we are supporting some of their thoughts on project phasing, etc., in the offshore wind environment. Because if nothing else, we have been in offshore wind since the beginning as the monopoly manager of the seabed. Without rights to the land from the Crown Estate, then these developments just don't happen. Simple as that. So again, around marine spatial planning, understanding how the areas of the seabed can be used to its optimum approach. The other sort of portfolios that we have within our business are, of course, urban. So you would immediately think of Regent Street, St James's, parts of Mayfair, Windsor Great Park, which of course is doesn't make much money, but is as huge as a reputational risk for us, not least because we've got some high-profile tenants there. And it also happens to be the emergency runaway for Heathrow, if anybody's interested in that.
Probably all learned at least one thing.
I'm not going to ask you which one it was, though. And so offshore wind is really, really becoming really important to our security of supply, our national energy policy. But so are all the other energy technologies there. And, offshore wind is intermittent, and it is that balance of technology and that balance of energy which we are trying, as in the offshore wind industry, are trying to promote and develop, both for security of supply and for a greener, better environment for us all. And here's an example of an existing wind farm, Robin Rig, on the west coast of Scotland, and what actually outputs for us. Now, I am, apologies if you all know this, but I'm just going to cover this basic slide in case anybody didn't get it. Because I had an assumption about a year ago, and somebody said to me, that's all very well, Dorothy, but how do you string the lines to the pylons over the sea? I said, well, actually, they don't go over the sea, they go under the sea. They stay in the seabed. Because the understanding was that it was like an onshore development where the cables actually were overhead and they weren't actually underground. And so this very simple slide will explain to you the size and the different components involved in building an offshore wind farm. So yes, you're going to have the obvious monopiles, gravity-based foundation, jacket structure. These are the substructure that the wind turbines will sit on. Developers will have to list the types of foundation within their planning application. And the types of foundation are usually based on what turbine they're putting on it, the depth of the seabed, and cost, ultimately. In the Moray Firth, they have water depths of 50 metres. So you have 50 metres of metal to get to the top of the water. Then you've got to have a little bit above the water. Then you have to have the bit that you can see here, the transition piece, the yellow piece, and then you've got the actual wind turbine. Now, I live in Fife, so I'm going to make a bit of a local example. For those of you who have been over the rail bridge, and I'm kind of guessing everybody here will have been over the Forth rail bridge, if you take the topmost peak of the rail bridge, you add on top, right, the Scott Monument. 200 metres is your tip height of a wind turbine in the offshore wind environment, the big. Each blade length, 60 metres, traditional, going up as we speak. So 60 metres blade length, the wingspan of a jet. Now you can say, crikey, people aren't going to miss that, are they? I mean, come on. But you have to balance the fact that these are up to 200 kilometres offshore. Some of them are 20 to 25 kilometres offshore, and therefore, for them, the visual impact from the line of the coast is less. But it isn't nothing, okay? But even when they get the consent, they then have to find around £1.5 billion of money over and above to build the wind farm. These developers are not entering the planning system lightly. They are not speculating. They are here for the long term. And therefore, getting a good planning consent, as quick as it possibly can, whilst ensuring that due process and diligence is followed, is really important to them. You know, both Mike and Ian, they talked about how fast technology has moved. And we see, you know, today, the work that Linknode has done on producing an app. Now, if we think about how long it takes from the beginning of an idea of a wind farm to actually getting it into the water, you think about that length of time and how much technology can change within that time frame. It's really important that decisions for infrastructure of national importance are as quickly as possible. Here's a typical project timeline to understand. So, you know, here we have a typical wind farm, the site awarded in 2010, January. These guys have got to spend 2 years collecting data. Then they have to analyse it. Then they have to put it into the planning system. Then you guys have got this really difficult job on the onshore side. Everybody's got a difficult job in planning. My heart goes out to you because, you know, there's going to be somebody that's not going to like it. And there's going to have to be a decision that is made. And you know, these projects are of critical importance, and generally developers, where they can, will cite it with visual impact in mind, because it's one of the things that goes into their 4,000-page application that everybody has to read. But even at the point of when consent is determined, and you know, in the positive world that it's a consent is granted, you know, National Grid, not them, but National Grid will give them a time when they can switch on. And in this example, a real-life example, they're given 2016, 6 years. So we use the example of a mobile phone. Well, the same example works on turbine technology. For those of you who, like me, have the benefit of living in Fife, yay, then you can go along to Methil and see the Samsung 7-megawatt machine, 220-metre tip height. Huge amount of money, £100 million gone into that machine as a prototype, on the hope that there will be a supply chain for Scotland, for the UK, to be able to get these turbines away. If we were having this conversation 7 years ago, we'd be looking at a 2.3, and we'd be going, ooh, maybe we could do a 3.6. Now today, that's the technology of today, but also it's very, very high demand. Going further out of shore, they're more expensive. Not least, if you think about it, the distance to get your power back to the main line. In the Moray Firth Zone 1, the first zone of the round 3 leasing round, they have 119 kilometres on the seabed to get their cable to shore. If they go for a particular type of connection on their electrical export, they will need to build a building the size of a mini B&Q to take their power in, to convert it, to put it onto the grid. So you might be sitting, why on earth have they invited an offshore wind person here? Because we'll never see it, it's miles away. It isn't miles away. The infrastructure needed to bring it to our homes is right on our doorstep. And it's understanding that complexity that's really, really quite key. And it's not just the wind farm. It's not just a decision for today. The leases that are awarded by the Crown Estate are 50 years long. They have an option after 25 years to repower. These sites need bases. They need operations bases. At one point in time, there can be 50 ships in the water servicing wind farms on one particular site. So the infrastructure, the longer term, what would happen if they change the size of their turbine because it's more economically viable in a couple of years after they've got their consent? What will that do to your local planning? Will you be able to change? How good would it be that you wouldn't have to blow dust off a photomontage and actually understand or try and think, oh no, the person's gone. What sort of assumptions were made when we looked at that onshore infrastructure? How good would it be if it was all digitalised and you could actually look quite quickly on the assumptions that are there? So it's a long-term gain. This is a picture, just to give you an idea of the operations and the onshore types of activities. This is the Beatrice demonstration project from the early 2000s, one of the first 5 megawatt machines that SSE was actually involved in a joint venture with an oil and gas company. So the learnings from the oil and gas technology was there because, again, we are in an offshore world environment. This is the site base. Now, again, there's a lot going on there that we need to take into consideration during that construction period. Offshore wind farms can take 2 to 3 years to construct, and then, as I say, 25 years to maintain. This actual turbine was assembled on the shore, uniquely, the first time ever done, and to date probably one of the only ones that's been done. And it was taken out like that. It wasn't taken out as individual components. It was assembled at 200 metres high, lifted up and carted out. So again, the visual impacts of that, very, very important. So to be able to look at all the different vantage points across the Moray coast and see what these kind of structures look like is really, really key. Some pictures here just to put it into perspective. Acres and acres needed for laydown areas. Major industrialisation of energy if offshore wind is to work. We've got 1,400 turbines out there, around the waters as we speak today. We've got offshore wind platforms out there too. So all the things around navigational, the sites that are nearer to shore, exactly what that impact is going to be is really, really, really critical. I'm going to leave you with one final thought because I'm conscious I probably talked a little bit too much on what is quite a passionate subject. There's nothing about offshore wind that is small. There is nothing about offshore wind that is short-term. Therefore, the ability to understand in a dynamic way how information data changes is really, really important to understanding the impact of hopefully the constructed out technology on our communities. A blade that would be quite normal in today's world, 60 metres, that's 7 double-decker buses. I say the laydown area the tip height, the construction of it, understanding the different dynamics of different turbines that might then be used. Planning consent will be put in, you know, maybe a year before the actual orders or the final engineering solution is finalised. Things will change. That's what the Rochdale envelope is all about. It asks developers in an offshore world to put in a range of planning options, and therefore being able to not only assess the impact of a building or a type of construction on the environment, but also the differences between the options is really, really, really key. And this is where I think, you know, and hopefully you'll share that view following Crispin's talk, which is now just about to start, you'll be pleased to know, will hopefully just give you that insight of how useful this tool could be in order to make those decisions quickly, optimally, and in the right way. Thank you.